please take a couple moments and practice these two warm-up problems, the sine and cosine problem. Keep in mind, please, that you have to factor out your b value before you can go through. So take a moment, factor out your b value, pause this for a second, do that, and then hit play so that you can see what it should be before moving forward. So these are the equations that you should be graphing. Keep in mind, one of them is sine, one of them is cosine, and they both deal with the transformations. So pause this for a moment, take about 5-10 minutes max, and go through and graph these, doing each of your shifts along the way. I'll graph the whole thing together and see if you can follow through. So pause it now, please. So we're going to start with the first one. So the first one is a sine graph. So when I take a look at this coordinate point, that point's 1, 0, so therefore sine starts at 0. Now, what I see here is my b value is 2, which means my period is 2 pi over 2. So my period is going to be pi. So start to start is going to be pi. So now what I see is, since this is sine and it starts at 0, I'm going to have this point starting at 0, and then pi is over here. So start to start is pi. Therefore, halfway between is pi over 2. Halfway between is my max, and halfway between is my min. There's one cycle. And then I can keep going again, halfway, halfway, half max, half min. So I'll just go with this one, or these two cycles. So now I'm going to look at my y values. So I'm multiplying my y's by 2, and then I'm going to be looking at adding 1. So I'm going to do that in one step. So when I multiply 0 by 2, I get 0, and then I shift it up one spot. I multiply 1 by 2, I get 2, and I add 1. 0 shifts up 1. Ooh, multiply by 2, and then add 1. Sorry about that. And then 0, I multiply by 2, and then I add 1, so that point goes up there. I'm going to erase these along the way, the ones that I've done in pencil. This negative 1, I multiply it by 2, which takes me down to negative 2, and then I add 1, which brings it right back up here. And then my 0 moves up, my max multiplies by 2, and then adds 1. My 0 value here moves up. This multiplies by 2, moves down to negative 2, adds 1, moves up, and then this 0 moves up here. I'm going to draw this graph along the way. Please keep in mind these should be nice little curves. Okay, so now I have that piece there, and the only thing I have to do left is add this pi over 4, but since it says plus, I'm going to actually go in the negative direction. Pi over 4. Pi over 4 is a space and a half. So every one of these points should move a space and a half to the left, because it says plus, therefore they move in the left direction. So 1 space and a half, 1 space and a half, which is right on my y-axis. Space and a half a space and a half. And provided I didn't miss any along the way, this should be a nice curve. And it keeps going in both of those directions. So there's the top one. Again, that was my sine graph. In the second one, that's my cosine graph. Cosine starts at 1. So for my cosine, I start by maxing out at 1. Looking at my b value, my period is going to be 2 pi over 1/2. So multiplying by the reciprocal, my period therefore becomes 4 pi. So start to start is 4 pi. So max at 1 and 4 pi is also at 1. Sorry, it's so light. There we go. And then halfway between at 2 pi, it's down at negative 1, and halfways are my zeros. I can also do this in the negative direction. And I have 2 complete cycles. So now what I have to look at is each of my individual transformations. So I'm going to do my multipliers again right away for my vertical, and then I'm also going to add my 2. So I'm going to do both parts at the same time. So I'm going to start here at my max, which was 1. I multiply that by 2, it takes me up to 2, and then I add 2, which goes all the way up here to 4. And then 0 times 2 is 0, plus 2. My min, negative 1 times 2 is negative 2, and then I add 2. Get rid of those values along the way that I've done already. This was at 0. Multiply by 2 gives me 0, and then add 2. And then 1 times 2 plus 2 takes me up here to 4. And then the other side as well. My min value is now at negative 2. And then at negative 4 pi, it's up at 4. My values that were at 0 are now at 2. And lastly, it says plus 3 pi over 2. Plus 3 pi over 2 means I'm going to go to the left, 3 pi over 2. So each of these points, 3 pi over 2, so that's 3, 6, that's 9 spots, or in other words, 3 big groupings. So this one here moves 1, 2, 3 pi over 2s to the left. This one's 1, 2, 3 pi over 2 to the left. And then this point is 1, 2, 3 pi over 2. This one goes 1, 2, 3 pi over 2. Negative 3 pi over 2. So there are all my points. And then I'm going to connect my dots nicely. So from that min value, curves up, min, back up, max, etc. So there's your graph of the 2 different sine and cosine functions with all of the transformations involved. So now we're going to move forward and we're going to look at tangent. So to begin with, please take a moment and graph the parent function for y equals the tangent of x. So pause it now and graph that. So when you graph tangent, you may wish to take a look at your unit circle a little bit closer, just so that you can get a look at what types of values you have. Because remember, tangent is always the sine over the cosine, and those values are going to take you a little bit more time to go through. So when I start with 0, and I do my sine over cosine, I get 0 over 1. So at 0, it's 0. And then when I look at pi over 6, it's 1/2 over the square root of 3 over 2, which is 1 over the square root of 3, which of course we can rationalize. Then here is nice. At pi over 4, it's the square root of 2 over 2 over the square root of 2 over 2. So pi over 4, it's 1. 1 is a nice case to have to deal with. Then I'm going to look at pi over 3. Pi over 3 is the square root of 3 over 2 over 1/2, which ends up being the square root of 3, which you might know approximately where that is. Then I go to pi over 2. Pi over 2 is 1 over 0, undefined, vertical asymptote. So you start going around, and it's really, really important that you understand which way you go through this. That parent function is incredibly important to have right, because we will definitely be graphing tangent with our parent function. So to begin with, I need to mark out some of my key important features. So as we started, I'm going to plot at 0 what happened at 0. So at 0, it was 0, because it was 0 over 1, which is 0. So then I went next to pi over 6, which is a single tick mark. At pi over 6, it ended up being 1 over the square root of 3. Not very nice. At pi over 4, which is, remember, 1.5 marks over, at pi over 4, it was 1. This is a really, really nice feature. And then I went to pi over 2. And at pi over 2, it was undefined. Since it's undefined, there is a vertical asymptote at that spot. Okay, so draw in that vertical line. It can never be there. Now, if I kept looking at values along the way, so we already figured out that at pi over 6, it was 1 over the square root of 3. And we looked at pi over 3, it was the square root of 3. So this graph looks something like that, at least in the positive direction. Now I keep going past pi over 2, and I go to 2 pi over 3. That's not very nice. At 3 pi over 4, it's at -1. So at 3 pi over 4, that's halfway between pi over 2 and pi, it's -1. And then my next one is not nice, and then at pi, it's -0, over -1, and 0 over -1 is 0. And then not nice again at 7 pi over 6, at 5 pi over 4, I'm back up to 1. And then I get back around to 3 pi over 2, and I get -1 over 0, which is undefined. Therefore, I have a vertical asymptote. There is a turn along the way that hopefully you guys remember seeing from doing your parent function. And that is your nice graph for tangent. Now, it's not 2 complete cycles. It's a cycle and a half. So if you notice, I have this upturn, I have this upturn. So it looks like over here I should have this downturn as well, and I should. So in order to tell that, I have to go in the negative direction. So if I go negative pi over 2, negative pi over 2 is also a vertical asymptote. Since this is positive pi over 2, from here up it's positive pi over 2, so from here down it's negative pi over 2, which again, that gives me a 0 in my denominator, which makes that undefined. And at negative pi over 4, it's -1. So there are 2 complete cycles. Now, when we do tangent, my recommendation is only 1 cycle. Only graph 1 cycle for tangent. And we will transform that 1 cycle, and then we will repeat the process. Now, for my parent, I did show you 2 of them, but my recommendation is only 1. Now, if you think about what our period is for tangent, this differs from our period for sine and cosine. If you take a look at when it starts to repeat again, from negative pi over 2 to pi over 2, that looks like 1 complete cycle. So between my asymptotes, or from middle point to middle point, from 0 to pi, that's 1 complete cycle. So for the period for tangent, it's actually just pi. And transformations, period is going to be pi over b. Big, big difference for tangent versus your sine and cosine. Without doing the next example, let's take a look at what types of transformations take place in this. So we will be graphing tangent functions that have a lot of transformations in them, but we're not going to graph this first one here. So my recommendation to you is first write it out so it's in transformation form. Y equals a tangent b parenthesis x minus c parenthesis plus d, so that you can see exactly what's taking place in terms of your tangent transformation. So please factor out what you were supposed to. Take a moment, pause this. So if I were to factor out this value, because it needs to just have an x inside here, this would be written as y equals 1/2 tangent of 2. So I factored out that 2, and then it's x plus 11 pi over 12 minus 2, or plus a -2. So what types of transformations are taking place? So the first thing that I'm going to look at is that b value, just like we've done before. So my period equals pi over b. So now, between any 2 specific points, it is going to be pi over 2. We are going to look at this as it's going around my y-axis, because remember, for the parent function of tangent, half of it's on one side of my y-axis, the other half is on the other side of my y-axis. So period, now half of it's going to be on the one side, so half of pi over 2 is pi over 4, and the other half, the other pi over 4, is going to be on the left side of my y-axis. And then, so this is dealing with my b value first. Then I'll look at my A value. My A value actually is taking part in a shrink by a factor of 1/2. Then I would look at my D value, which means this is going to be a downward shift of 2 units. And then lastly, I have my C value, and my C value is going to be a shift to the left, 11 pi over 12. That's pretty ugly to have to try to shift. It's just a little bit, oh, that's off there. That's just a little bit less than pi, but it's going to be a left shift of 11 pi over 12. So those are the different types of transformations that are taking place in this equation. So now let's actually look at graphing one. Now, just in case you mess up, or even if you just need to clean up your graph a little bit, that's part of the reason I have this bottom one here. So that if you need to, or if you make a mistake along the way, you can then just rewrite it down below. So to start with, I'm going to use pencil again so I can erase along the way. That way you can see each of the transformation pieces that are taking place. The first thing that I'm going to look at is my B value. Fortunately, B has already been pulled out for you. So I know that my period, which is normally pi over B, is now pi over 1/2. Multiply by the reciprocal, so therefore my period is 2 pi. Half of my period falls on the right-hand side of my y-axis, the other half falls on the left side. So whatever this period is, take half of it. That's where your vertical asymptote falls. So half of 2 pi is now pi, where my asymptote is. And the other half is on the other side. So now when I take a look between my two asymptotes, there should be 2 pi. So there's a pi on this side, there's a pi on this side. So that gives me my 2 pi that I should have on both sides. So far so good. Now, my parent function starts in the middle and opens up and opens down. So that's about the way the graph initially looks until we start performing some transformations. So I have to look at what types of transformations are taking place. I'm going to look at my multiplier. I know no matter what, I have this 0 here until I start doing some shifting. So I'm going to start with my 0 point here. And then normally I had a point halfway over and one up. So now everything's halfway. Asymptote, asymptote, halfway, halfway, halfway. So I'm going to do my halfway points. Pi over 2, that halfway point is usually up at 1. However, I have a multiplier of 2. So that 1 is going to multiply by 2 and comes up to positive 2. Then my other halfway point, which would have been at negative pi over 2, that would be down at negative 1. However, that's multiplied by 2, so that comes down to negative 2. And of course, 0 times 2 is 0. That's why I always know I have that 0 value in the middle. So these are my 5 key points. Asymptote, asymptote, halfway between, halfway between, halfway between. Tangent always goes up and to the right and down and to the left. Now I'm going to look at my shifting plus 3. So I'm doing everything in the same order. First I deal with my B value, then I deal with my A value, then my D, and lastly my C. So now I'm going to take all of my points and move them up 3 spots. Here's the nice thing. Asymptotes don't move. So the only thing I'm actually going to move are those 3 points. So my center point adds 3. So it comes up here. My pi over 2 adds 3. So it comes up here. And then this was at negative 2. It adds 3. So now it's up here at 1. So now I have my 3 inside points. My asymptotes don't shift, which is kind of nice. The last thing that I have to do, so I've done the 2, I've done the half, I've done the 3. The last thing I have to do is the minus pi over 6. Since it's minus, I move everything pi over 6 to the right. It's the opposite. Therefore, my asymptote shifts pi over 6 to the right. Pi over 6 is one little spot. So this asymptote moves pi over 6 to the right. This point moves pi over 6. This point moves pi over 6. This point moves pi over 6. and this asymptote moves pi over 6. So all of my values move pi over 6 to the right because it was a minus sign, so it moves in the right direction. Now I'm going to extend this up just a smidge because I am so close here. This is my turning point. It's important. From your turning point up into your asymptote, and from your turning point down and towards your asymptote. This should be a nice curve. Nice curve going from that turn. Point, point, point. And then I'm going to erase these other lines along the way because that asymptote is no longer there. This asymptote is no longer here. And these points are also not here. So there's one individual cycle. So now I can go out. One more cycle out. This is where it gets a little bit harder. What I would recommend is at this point, before you do the horizontal shift, you might want to make another cycle. Otherwise, I know my last one ended at pi, so I have to go 2 pi out from there, which is 3 pi, plus 1 more to the right, because everything shifted pi over 6 over. And then my center was at pi. It's now going to be at, or excuse me, it was at 0. It's now going to be at 2 pi plus an additional 1. And then that's up here, because that's at center point. And the other one is 1 dot past, which is here, and 1 dot past up at this height here. Turning point, turning point. Graph should look pretty similar. But that is the graph of your tangent with all of your different transformations involved. Now, with tangent, there are other things that we're going to take a look at. I shouldn't say tangent, but just in general, having some negative multipliers as well. You may wish to pull out an extra sheet to put a couple more notes on. Otherwise, you can just keep going on your tangent sheet if you can fit this in here. But a couple other things with transformations, because now we've done all transformations with sine, cosine, and now with tangent. The only difference with tangent, again, is it goes around your y-axis versus always starting at 0 and going to the right. So it's one of your big differences. Half's on one side of your y-axis, half is on the other side of your y-axis. Now, a couple other things to keep in mind is we may have negative multipliers. There are 2 places for negative multipliers. So in one case, it could be y equals the sine of negative 2 times x. So the negative is affecting your x value because the multiplier here is actually on your x. If this is the case, it will reflect over the y-axis. So when you're doing your graph and you do your multiplier first, multiply that number, and then you're going to physically take everything that you have and reflect it over your y-axis. So that's if there's a negative on your x. If there were a negative in front, the opposite of the sine of x, this negative is actually affecting your y because I can divide both sides by a negative and it's physically attached to your y. If that's the case, when you do the part that's affecting your y, which is your amplitude, when you get to that point, then you are going to reflect over the x-axis. So this axis, if you were to ever have a negative y value. So keep in mind which negative controls which piece. The last part that we're going to look at is what are called even and odd functions. You'll see this in more than just trigonometry. However, this is a nice place to kind of introduce even and odd functions. If we have an even function, it looks like the following: f of negative x. So if I take all my x values and change the negativity of it, the result is the same y value I would have had if my x was positive. So it does not matter whether my x is negative or positive, my outcome value is the same. My dependent variable is going to be the same. An example of this would be a quadratic. This is without any other transformations taking place here. In my quadratic, whether I put a positive one in or a negative one in, they both give me the same output value, the same y value. Even functions, a couple of ideas with them. Even functions have a symmetry as the y-axis. So I can put a mirror down my y-axis and it reflects onto itself. So another example of an even function would be cosine theta. Because cosine theta starts at its max, and then down to its min, and then back up to its max. If I were to reflect this over, whether I go positive 2 pi or negative 2 pi, positive pi over 4 or negative pi over 4, my y values are exactly the same. So cosine is another example of an even function. Even functions occur when I only have an even exponent, or cosine is another example of an even function. An odd function occurs when I take f of negative x. So I change my x value and I make it negative. The result, the outcome value, is a negative 1 times the y value if I put in the positive x. So if I put a negative in for x, it's a negative of the same exact outcome value that I would have had before. In this case, it's rotational symmetry. And it's about the point 0, 0. So an example of this one, with what we're doing right now, would be the sine of theta. Sine is odd because when I graph this, I'll make this one look a little bigger. It starts at 0, 0, 0. So this goes up and down and up. This rotates itself. It turns it around and comes back down and up and down. So it rotates itself about the point 0, 0. That's rotational symmetry. That is an odd function. Another example would be tangent. Tangent theta, tangent x. Tangent I take this and I rotate it around and it goes down here. Okay. Odd functions are going to be rotational symmetry. So y equals x cubed. A cubic, where I don't have any squareds or anything in there, no evens with it, just this odd, is going to also be an odd function. They're even, they're odd, or they're neither. They don't fit either of these symmetries. But for what we're looking at, cosine is our even function, and then sine and tangent are both our odd functions. So now that we've gone through this information, what you are going to work on now is a tangent transformation sheet, making sure that you can graph all of your tangents through transformations. Please keep in mind the negative multiplier. It doesn't happen all that often, but you may see it along the way. It'll be bigger when you get to pre-calc. If you have other things to work on as well, any other worksheets you have not finished, please make sure that you do those as well. That way all your graphs are really, really solid for when we start writing equations. Because writing equations goes backwards of graphing. So now work on that worksheet and make sure you guys check your answers.